Let's go to page 204 and let's do number 286. Okay, so it says the graph of the equation x plus 3y equal to 6 and kx plus 2y equal to 12 are perpendicular. What is the value of k? Okay, so the slope of these is, so slope equal to negative a over b, so negative 1 over 3. The slope of this one, I'm going to call it perpendicular, okay, equal to negative a over b. Okay. Now the relationship between them is that they are negative reciprocal, or when you multiply together, we equal to negative 1. Okay. Again, when you have the perpendicular line, okay, this way they are negative reciprocal. So if the slope is a over b, this will be equal to negative b over a. Okay, and so when you multiply the two together, it will equal to negative 1. Okay, so in other words, negative 1 over 3 times negative k over 2 equal to negative 1. Okay, so if you cross multiply, you're going to get k equal to negative 6. And that's it. Okay, the negative 1, negative k give you positive k. And that's the answer for that. Okay, let's go to page, let's go to 287. What are the coordinates of the point that are 2/3 of the way from 2,4 to negative 1, 1? So you can sketch it out, or you can just do two-dimensional sketch. Okay, so here's your point A, here's your point B. So point A is 2,4, and point B is negative 1, 1. And you're looking for 2/3 of the way. You're looking for a point that's 2/3 of the way. So this is 2/3 and this is 1/3. Okay, so you can do it by formula, or you can just do it analytically. So let's do the x first. So this would be the xy. So to figure out the x, so the way to derive formula is, first you're going to use negative 1 minus 2. So negative 1 minus 2 give you the whole distance. Then you're going to times by 2/3 to get this distance. Okay, so again, negative 1 minus 2 give you this whole length. You times by 2/3 give you this length. Then you have to add the coordinates where you start. So you start at 2 and you add this length, that will give you the x. You do the same thing with y. So y, you're going to have 1 minus 4. Okay, so 1 minus 4 give you this whole length. You times it by 2/3 to give you this length. Then you have to add the starting value to get this coordinate. Okay, again, you start at 4. Right, start at 4. You add 2/3 of the distance. Okay, so from here you add this, will give you the y. And you just go and work it out. So x will equal to 2 plus, so this will be negative 3. So x will equal to 2 minus 2. So x equal to 0. This one you got y equal to 4 plus, this would be negative 3. So cancel out, so y equal to 4 minus 2, so y equal to 2. So the coordinate of the p would be 0, 2. Okay. Okay, let's go to 288. So we are giving the line 3x plus 5y equal to 15, and a point on this line, equidistant from the coordinate axis. In which quadrant can such a point exist? Okay, so well, first let's go and sketch these things out. So you got, so if you did x equal to 0, then y will equal to 3. If you let y equal to 0, x will equal to 5. Okay, so 0, 3, right over here, and 5, 0 is right over here. Okay. So you're looking for a point on this line is equal to the axis. Okay, so example of that would be like this point right over here. Okay, you see it's equal distance. Okay, so this would be in quadrant 1. Now there's another possibility. Okay, if you have like a point like right out here somewhere, so it's going to have equal distance to that. Okay, so this will be quadrant 2. So answer would be 1 and 2. Okay, so again from here, this point over here equal distance, this point equal distance. Okay. Another way to think of it is that to have equal distance, you have to have a 40-degree line. So you have the x equal to y. So if you draw the x equal to y or x equal to negative y, see over here, you can have that point. Okay, let's go and draw this. Here's a red. Okay, so you have to be on this line like this. Okay, so that's that point. You also can have another possibility. If you draw this is a 45 degree line, you also can draw the 135 degrees. So like this. And again, you get this point right over here. Okay? So again, to have equal distance to the axis, you have to draw the 45 degree or 135 degrees. And you can see that you intersect at 2 points. Okay, let's go to number 289. Okay, this is a proof. Prove analytically that diagonal of the rectangle bisect each other. Okay. Okay, so you have this rectangle, okay, and I'm going to put it against the origin. So point A is going to be at 0, 0, and I'm going to call this side A and call this B, the length. That means this coordinate B will have coordinate of A, comma 0. And this point I'm going to label as C, will have the coordinate of AB. And this point D will have a coordinate of 0, comma B. Okay, so now you're going to prove that you're going to prove that diagonal of the rectangle bisect each other. Okay, so what I'm going to do is I'm going to draw this over here. I'm going to find the midpoint of this diagonal. Okay, so midpoint of this diagonal, I'm just going to average the two, right? So I'm calling this M. So the midpoint M for this diagonal will be average of 2. So again, midpoint is just average the 2. So you're going to get A over 2 and B over 2. Right? That's that midpoint. Then I'm going to get the midpoint of this diagonal. Okay. Now at this point, I don't know if they are the same or not. So I'm going to call this point M. For the red diagonal, the midpoint, again, you average the 2. So you average, you're going to get A over 2. Right? You add, divide by 2. This one you add, you're going to divide by 2. And then you compare. Well, since both are same, so since both have the same midpoint, so AC and BD have same midpoint. Okay, therefore they bisect each other. Okay, and that's it for this one. Okay, so again, the midpoint of this diagonal is blue M, which is have this coordinate. The diagonal of the red diagonal, the midpoint is this, and since they are identical, Therefore, it's an identical point. Therefore, they bisect each other because it's a midpoint for both diagonal. Okay, let's go to next one. So page 204, number 290. Okay, it says find y if you have a 3y lies on the line join. So 3y is on this line over here. So you got these 2 points. So you got 0, 3 over 2, and then you have 9 over 4, comma 0. And so you want to find y if this line lies on this line over here. Okay. Okay, well first let's going to find the slope of these, because if this point is on this line over here, all this will have the same slope. So if you take this, if you find the slope of these, then this will have the same slope. Okay. Okay, so let's find the slope of this one. So slope will equal to this minus s would be 9 over 4. Let's double check. Oh wait, it's y. So it would be y2 minus y1 over x2. So that's your x1, y1, x2, y2. This minus that over 9 over 4 minus 0. Okay, and then so m equal to negative 3 over 2 over 9 over 4. And you can use the outer over inner. Or you can just divide. Again, there are many ways you can do this. And then you can go and simplify. So m equal to negative 2 over 3. Okay. Now, since this point is on this line, okay, you should have the same. You should have the same slope when you subtract. Okay. So again, there are many ways you can do this. You can use the equation. Okay. You can look for equation first, then you can substitute in there, or you can just use the slope. Again, since this point is on this line, so this way you have the exactly same slope. You can use this. You can use that. Okay, so you're going to have the slope equal to, let's see, which would be easier. I'm going to use this minus this, okay? I'm going to, let's use this too, okay? So I get, let's use this too. That, because it's solving for y. So you're going to get y minus 0, so this minus that, over 3 minus 9 over 4. There you go. Okay, so you simplify it, so you can multiply over, so you got y equal to negative 2 over 3 times, so your minus, so this one will give you 3 over 4, right? 3 minus 9 over 4, this is 12 over 4, minus 9 over 4, give you 3 over 4. When you work it out, you got y equal to negative 1 over 2. Okay, and that's it. Okay. Now you're going to get the same result if you use these 2 points instead. Okay, let's say again all 3 are on the same line, therefore it doesn't matter what you have, you should have the same slope. So let's say if you use these 2, okay, so you're going to have the slope equal to, wait, what did I use first? I used these 2 first, so I'm going to use these 2 next. Okay, so I'm going to use these 2 now. So let's say this one, so you're going to get y minus 3 over 2 over 3 minus 0. Okay, so from here you can just cross multiply, so you got negative 2 equal to y minus 3 over 2, right? So more over, and then you plus 3 over 2 plus 3 over 2, so you got y equal to negative 1/2. So either way you get the same result. Okay? Okay, let's go to 291. Okay, describe analytically all the lines which bisect the area of the square with the vertex C at 0, 0, S0, SS, and 0, S. Okay, so you have a square, and the vertices are 0, 0, then S0, then you have the S, S, and 0, S. Describe the analytic all the lines which bisect the area of the square. Okay, so to bisect the square, it must go through the center of the square. Okay, so you just have a random line going through like that. Okay, so you must go through this line right over here. Go through this point, the center. The center is going to be S over 2, S over 2. Okay, and this point over here, it's going to have the coordinate of 0, comma, y. Okay. So now we can go and find the equation. Okay. So the slope is equal to the y2 minus y1 over x2 minus x1. Okay, so multiply, so you have complex fraction, multiply everything by 2 to simplify the complex fraction. So this will cancel out, so you get s minus 2y, over here you get s. Okay, so that's the slope. And now you can use the point slope form. Okay. So you're going to get y minus s over 2 equal to the m. So you basically use the equation y minus y1, the point slope form. Okay, so that's what I'm using over here. Okay, so y minus y1 equal to the slope times x times x minus x1, so s over 2. Okay, so, and that's it. Okay, so you can just leave it like that. Okay, so there are a whole bunch of equations, right? You can have any equation as long as it goes through that. So this is a family of the lines. So this is the equation for the family of lines. Okay, let's go to 292. Okay, from the vertices of a square which center is at, okay, so you have a center at negative 17, 23, and has a side length of 4. Okay, so side length of 4, and the diagonals are parallel to the coordinate axis. Okay, so the diagonals are parallel to the axes, so that means that the square is going this way, and you have length of 4. Okay, so again, diagonals are parallel to axes, so that means diagonals are vertical and horizontal, and the square has length of 4. Okay, and so you're looking for the vertex C. Okay. Okay, well, if this is a 4, then this would be 2 squared of 2, 2 squared of 2. Okay. And therefore, this coordinate, okay, you start with negative 17, 23. Okay. So this one, when you go sideways, you add onto the x. So it would be negative 17 plus 2 squared of 2, comma, 23. This point, again, you start out as negative 17, 22. When you go down, that's the, you have to go down, that's the y. So it would be negative 17, 23 minus 2 squared of 2. Okay? This one, when you go this way, you have to minus the x. So it would be, let's write down here. So it would be negative 17 minus 2 squared of 2, comma, 23. Okay? And this point, you go up, you have to add onto the y. So it would be negative 17, comma, 23 plus 2 squared root of 2. Okay, and those are your 4 coordinates of the vertices. Okay, let's go to 293. This one, the instruction is a little bit confusing. Okay, So a circle is drawn with a center at the origin and radius 3. Find the coordinate of all the intersection of the circle. So the square is made out of the lines, okay, not segments. So that's where it's kind of where the confusion comes in. Okay. So okay, so you have this center, right? You have this equation over here. Okay, so it's centered at here, and the radius 3. So this would be, so this is 3. So again, these are the 3 units. And you have a square formed by these 4 lines over here. So you're looking for intersection points, right over here. Okay, you're looking for those points. Okay, well, the equation of the circle is x squared plus y squared equal to 9, right? Because the center is 0, 0, and the radius is 3. So that's your equation. Okay, and so when you have so over here, this is your x equal to 2, x equal to negative 2, and y equal to 2, y equal to negative 2. So when you substitute this value into here, you can find those points. So for x equal to plus or minus 2, okay, you're going to get 4 plus y squared equal to 9. So y squared equal to 5. So y equal to plus or minus square root of 5. Okay. So for those points, you're going to get plus or minus 2, comma, plus or minus square root of 5. Okay. So when you have x equal to plus or minus 2, so you get those 4 points. So those are those 4 points, the red ones. Okay. So these are the red ones. Okay, now let's go and do the blue ones. Okay, that is when y equal to plus or minus 2. Okay, okay, I'm using this. Okay, so then you substitute into here, so you're going to get x squared plus 4 equal to 9. So x squared equal to 5. So x equal to plus or minus square root of 5. So the blue set, the blue points are plus or minus square root of 5, comma, plus or minus 2. Okay, so those are the 8 points that will intersect between the lines that make the square with the circle.